Hi guys, I'm Archibald Picaro. Today, we're going to solve some problems involving the topics for finals in Calculus 2. So without further ado, let's start and solve some problems. These are the topics for finals. We have A, the indeterminate form and Cauchy's mean value theorem. B, other indeterminate forms. C, improper integral with infinite limits of integration. D, other improper integrals. So each topic, we are going to solve one problem for each of the topics. So let's start with letter A. This is the first problem for the first topic, which is find the required limit. We have here item number 66, which is limit x cubed over e to the power of 2x, where x approaches to infinity. So to solve this problem, let's first try the direct substitution. We have limit x approaches to infinity, x cubed over e to x. By direct substitution, let's substitute infinity to our x. So we have infinity cubed over e to the power of 2 infinity. Ayan. So infinity cubed, which is infinity, over 2 times infinity, which is infinity. Infinity over e to the power of infinity, which is infinity. See, this is indeterminate. Determinate form. Infinity over infinity. Therefore, apply L'Hopital's rule. So let's apply the L'Hopital's rule. Limit x approaches to infinity, x cubed over e to the power of 2x. Now let's apply the L'Hopital's rule. Remember that the L'Hopital's rule says that if you have f of x over g of x, you're going to find the derivative of f of x. So we have f prime x over g mx. That is the L'Hopital's rule. So let's apply the L'Hopital's rule to our problem. So let's start. So copy limit x approaches to infinity, x cubed over e to x. Copy the limit x approaches to infinity. This is our fx and this is our g of x. So let's find the derivative of x cubed. So the derivative of x cubed, which is 3x using the power root. 3 minus 1, which is 2. So 3x to the power of 2 over e to x. Using the chain rule, so first we have e to x times the derivative of the exponent, which is 2. So limit x approaches to infinity, 3x squared over 2e to x. Since we already found the derivative, so let's substitute again the infinity to our x. So let's start. 3 infinity squared over 2e to infinity. So infinity squared, which is infinity, and infinity times 3, which is also infinity. We have here 2 times infinity, which is infinity. So 2e infinity over 2e infinity, which is infinity times 2, which is also infinity. So it is, again, it is indeterminate form, infinity over infinity. Therefore, apply again the L'Hopital's rule. So, in applying again the L'Hopital's rule, we're going to use this equation na. Since we already derived the equation, so let's derive it again. So that is the rule. So let's copy this. So we have limit x approaches to infinity, 3x squared over 2e to the power of 2x. So let's apply again the L'Hopital's rule. So copy limit x approaches to infinity, 3x squared over 2e 2x is equal to, copy the limit x approaches to infinity. What is the derivative of 3x squared? So using the power rule, so let's the exponent times the coefficient, which is 3. So we have 6 and 2 minus 1, which is 1. So magiging x now. So 6x over 2e 2x. So the derivative, we have, using the chain rule, 2e 2x times 2. So limit, copy the limit x approaches to infinity, copy the 6x over 2 times 2, which is 4e 2x. So substitute again the infinity to our x. So 6 infinity over 4e to infinity. So 6 times infinity, we have infinity over 2 times infinity, which is infinity, and e to the power of infinity, which is infinity, and 4 times infinity, which is also infinity. So since this is indeterminate form again, determinate for infinity over infinity, therefore let's apply again the L'Hopital's rule. Since this is the second derivative, we're going to use this equation to find the third derivative. So let's copy the equation rather. So we have limit x approaches to infinity, 6x over 4e to x. Now let's find again the third derivative. So let's start. Limit x approaches to infinity, 6x over 4e to x, which is, copy the limit x approaches to infinity. The derivative of 6x, which is 6. And for e to the power of 2x, derivative of it is, we have 4e2x times 2, chain rule. So, copy the limit, x approaches to infinity, 6 over 2 times 4, which is 8, e 2x. Substitute the infinity to our x, so we have 6 over 8 e to infinity. So, copy the 6, 2 times infinity, which is infinity, and e times infinity, which is infinity, and 8 times infinity, which is also infinity. Now, 6 over infinity, this is 0, meaning the limit exists. So the required limit is 0. Now the graph of it is this. Now let us proceed to our second topic, which is the other indeterminate forms. So let's have this problem. We have described the type of indeterminate form that is obtained by direct substitution, evaluate the limit using L'Hopital's rule, use a graphing utility to graph the function. This is our problem, or our equation, which is limit x approaches to 0, cosine pi over 2 minus x to the power of x. So let's try to address letter A, which is through direct substitution. So let's try. So we already copied the equation or the function. So let's try to direct substitution. Let's try the direct substitution. So copy the function limit x 0 approaches to 0, cosine pi over 2 minus x to the power of x. So through direct substitution, let's substitute the 0 to our x. So we have cosine pi over 2 minus 0 x. 0. Sorry. So pi over 2 minus 0 is pi over 2. So cosine pi over 2 to the power of 0. So cosine pi over 2, which is 0, and the pt power, which is the exponent rather, which is 0. So this is the type of indeterminate form we obtain by direct substitution, which is 0 to the power of 0. There are other types of indeterminate form, which is this one, which is 0 to the power of 0. We also have 1 to the power of infinity and infinity to the power of 0. These are the other type of indeterminate form. Now let's evaluate the limit using L'Hopital's rule, which is this is letter B. But before we're going to evaluate the limit, let's try first to rewrite the expression. So limit x approaches to 0, cosine pi over 2 minus x to the power of x. Remember that cosine pi over 2 minus x is equivalent to or equal to sine x by right angle triangle properties. So meaning, we can substitute this expression, this inside the bracket, the cosine pi over 2 minus x to sine x. So let's limit x approaches to 0, sine x, substitute, and x. This is now our new expression, new function. So let's try to substitute the 0 to our x. So sine 0 to the power of 0. Now, sine 0 is 0, right? And to the power of 0. Again, this is the other type of indeterminate form. So if we have this type of indeterminate form, let's try to take the logarithmic or yes. So let's try to assume that the limit exists and is equal to y. Take natural logarithm of each side. So meaning, let's use this expression. So magiging y is equal to limit x 0 sine x power of x. Get the ln of y, so magiging ln y. Take natural logarithm of each side, so ln y, and also ln limit x approaches to 0 sine x to the power of x. Now let's use this function to evaluate the limit. So I copied the new expression, so let's try to evaluate this one. So let's put the limit outside. So limit x approaches to 0 ln sine x to the power of x. Remember that we can rewrite this expression by the rule of logarithm. So we can put the exponent in front of our ln. So magiging x ln sine x. So we have new expression now. We can also rewrite this expression. This expression is equivalent to limit x approaches to 0, which is ln sine x over 1 over x. Now, if we're going to substitute 0 to our x, so we have now ln sine 0 over 1 over 0. So ln sine 0 is 0, right? And ln 0 or 1 over 0, it is negative infinity over infinity, where x approaches to 0. So negative infinity over infinity is indeterminate. Therefore, apply L'Hopital's rule. Let's use this expression to use the L'Hopital's rule. Now, let's apply the L'Hopital's rule. We have limit x approaches to 0 ln sine x over 1 over x. So let's take the derivative of the numerator and the denominator. So copy the limit x approaches to 0 And the derivative of ln sin x using the chain rule, we have 1 over sine x times the derivative of sine x, we have cosine x over 1, the derivative of 1 over x. Let's try to evaluate 1 over x. The derivative of it is, let's try to rewrite. So this is the same as x to the power of x to the power of negative 1, right? So the derivative of it is using the power rule, so negative 1 times x, negative 1 plus minus 1 rather, so magiging negative 2. So therefore negative 1, let's put it again to the denominator, so x squared. So derivative of 1 over x is negative 1 x squared. So let's multiply the numerator, so copy the limit, x approaches to 0. It is 1 over sine x times cos x is cos x over sine x over negative 1 x squared. Now, as you can see, cosine x over sine x is same as, we can rewrite it as cotangent x. Copy the denominator, which is negative 1 x squared. Now let's divide the denominator to our numerator. So limit, copy again the limit, x. If we're going to divide, let's multiply. Gain 1, multiply the reciprocal of this numerator, so negative x squared over 1. So this cotangent x over 1, we can rewrite this as 1 over tan x. So limit x approaches to 0, just ito magiging 1 over tan x times negative x squared. So this one, sorry. So let's multiply. So it will going to negative x squared over tan x. Now let's try to substitute 0 to our x. Let's apply the limit. So negative 0 squared over tan 0. Negative 0 squared, we have 0. And tan over 0 is 0. Since it is indeterminate, we can apply again the L'Hopital's rule. Let's use this expression, this new one. Now let's apply again the L'Hopital's rule to our new expression, which is, this is the first derivative of our function. So let's take the derivative again of this function. So we have, copy the limit, x approaches to 0. So the derivative of negative x squared, which is power rule, so 2 negative x, so magiging negative 2x over tan x, the derivative of tan x, which is secant squared x. So let's apply the limit. Let's substitute 0 to our x. So negative 2 times 0 over secant squared 0 is equal to negative 2 times 0, which is 0, over secant squared 0, which is 1. So 0 over 1, which is 0. Now, remember that this is ln y, since we take the logarithmic of our ln y, logarithmic of our y rather. So magiging ln y is equal to 0. So y now is equal to e0. So y equal to 0 is 1. Since ln y is equal to 0 and y is equal to 1, we obtain limit x approaches to 0. Sorry for that. Sine x. Is this sine x? The power of x is equal to 1. Therefore, limit x approaches to 0, cosine pi over 2 minus x to the power of x is also equal to 1. The limit exists. Now, the graph of the function y, we have y is equal to cosine pi over 2 minus x, the power of x, looks like this. Now, let us proceed to our third topic, which is the improper integral with infinite limits of integration. Now, I have here a problem involving improper integrals with infinite limits of integration. So we have here determine whether the improper integral diverges or converges. We have item number 36, integral from 0 to infinity sine x over 2 dx. So, to evaluate this function, let's observe first our problem. As you can observe, we have an upper limit of infinity, right? So meaning, the function is continuous on the interval a infinity. Since the function is continuous on the interval a infinity, then we can use the first definition, which is integral a integral from a to infinity fx dx is equal to limit b approaches to infinity, integral from a to b fx dx. Now we can use this definition to evaluate this function. So let's start. Solve in. We have integral infinity to 0 sine x over 2 dx. So our definition, we have limit b approaches to infinity, integral from a to b, which is our a is 0, right? So 0 b f of x, no, our f of x here is sine x, right? Sine x over 2. So sine over 2 sine x over 2 dx. Now, before we're going to apply the limit, let's first integrate this function. Now, to integrate this function, let's use the substitution method. So let u is equal to x over 2 du, which is ito magiging 1/2 x, right? So magiging 1/2 dx, so dx over 2. And our dx now is 2 du. So let's substitute this to our function. So copy the limit. B approaches to infinity. Integral from 0 to b, which is sine x over 2, which is u. And our dx now is 2 du. So times 2 du is equal to, let's multiply. So limit p approaches to infinity, integral from 0 to b. So sine u times 2 du, which is 2 sine u du. Now let's copy this function. Wait. So we have limit b approaches to infinity, 0 to b, 2 sine u du. Now, since we already copied, so let's continue. Let's integrate. But before we're going to integrate, let's put the constant outside the integral. So limit b approaches to infinity, which is 2, integral from 0 to b, sine u du. Now let's remember, let's use this again, the values of this one. So limit b approaches to infinity, we have 2, the integral of sine u du, which is cosine, right? So cosine u. Let's remove the integral because we're going to integrate the sine u. So cosine u from 0 to b. Now let's put this values to our function. So limit b approaches to infinity, 2. Now wait, the derivative of the integral of sine is negative cosine, right? Therefore, ito magiging negative 2 cosine. The value of u is x over 2, right? So let's put x over 2. Let's bracket 0 to b. Now let's subtract the upper and lower limit. b approaches infinity. Now negative 2 cosine, our upper limit is b, so b over 2 minus negative 2 cosine, our lower limit, which is 0, so 0 over 2. Next, copy again the limit. b approaches to infinity. Now, copy the negative 2 cosine b over 2 minus eto, let's distribute negative to our function. So negative times negative is positive. Now negative 2 cosine 0 over 2. Cosine 0 over 2 is 1, right? So 1 times negative 2 is negative 2. And negative 2 times negative, which is positive 2. Now let's apply the limit. So let's substitute infinity to b. So negative 2 cosine infinity over 2 plus 2. Now infinity over 2, which is infinity, right? So negative 2 cosine infinity plus 2. Remember that cosine infinity is undefined, right? Because the function oscillate indefinitely between negative 1 and 1. So therefore, the improper integral diverges. So that's our conclusion now is, since cosine infinity is undefined because the function oscillates indefinitely between -1 and 1. Therefore, the improper integral diverges. Now let us proceed to our last topic, which is the other improper integrals. Now, I have here a problem involving other improper integrals. We have here, determine whether the improper integral diverges or converges. So we have item number 48, which is integral from 0 to 5 of 1 over 25 minus x squared dx. So as you can observe to our problem, if we're going to substitute 5 to our x, it will become undefined. So therefore, if function is continuous on the interval a to b, we have a to b, and has an infinite discontinuity at b, which is r5, since diba, 5 will make our function undefined, diba? So meaning it has an infinite discontinuity at b at 5. So therefore we will use the first definition at 5. So we will use the first definition. The first definition says that if we have a b f of x dx is equal to limit of c approaches to b negative, we have c a fx dx. Now let's use this definition. So solve in integral 1 over 25 minus x squared dx is equal to, let's use this definition. So we have limit c approaches to rb is 5, right? So 5. We have ra is 0, c fx is 1 over 25 minus x squared dx. So let's integrate this first. Now, as you can observe, our denominator to our function is factorable, meaning we can factor it. And the factor of 25 minus x squared, we can write it as 5 minus x and 5 plus x. So we can apply here a partial fraction. We can apply the partial fraction. So ito magiging 1 over 5 minus x plus, not plus, 5 plus x. Ito. Ayan. Now, let's focus muna dito. So, let's apply the partial fraction. So, ito magiging a, it is 5 minus x plus b 5 plus x. Now, let's multiply both sides by 5 minus x 5 plus x. So, ito magiging cancel na ito. Magiging 1 na lang. So, a over 5 minus x times 5 minus x and 5 plus x. So mag-cancel. So magiging a. Cancel din ito. So 5 plus x na lang. 5 plus x. Now, plus b over 5 plus x times 5 minus x and 5 plus x. So cancel si 5 plus x din. So magiging b 5 minus x. So let's distribute. So magiging a5 plus ax plus b5 minus bx. Let's combine the ax minus bx. Not combine, group. Plus a5 plus b5. 1. So let's find the value of a and b. So let's start with our equation 1, which is ax minus bx is equal to 0. This is our equation 1. So we have a minus b is equal to 0. So therefore our a now is equal to b. And this value, let's substitute this value to our equation 2, which is our equation 2 is a5 plus b5 is equal to 1. So a now is become v. So this is our equation 2. So b 5 plus b5 is equal to 1. And b5 plus b5 is b10. No, b10. b10 is equal to 1. Divide both sides by 10. So we have now the value of b. b is equal to 1 over 10. And let's substitute the value of our b to our equation. This is our equation 3. So we have a now is equal to 1 over 10. So the value of a is 1 over 10 and our value of b is 1 over 10. Now let's go back to our function. So ito magiging limit c approaches to 5, integral of 0 to c. Magiging na itong our value of a is 1 over 10. 1 over 10, 5 minus x. Same with the other one, which is 5 plus x. So magiging 1 over 10, 5 plus x. Don't forget the grouping symbol and the dx. Now let's continue. We can put the 1 over 10 outside the integral. So magiging limit c approaches to 5, 1 over 10, integral from 0 to c. We have 1 minus 5, 1 over 5 minus x plus 1 over 5 plus x dx. Let's copy this. So to integrate this, let's first integrate the 1 over 5 minus x. So let's try to integrate. So we have 1 over 5 minus x dx. So we have, let's use substitute. So let u is equal to 5 minus x. du is ito magiging negative 1, negative dx. And our dx now is negative du. So let's substitute. So 1 over u times our du, which is negative, our dx is negative du. So ito magiging negative 1 over u du. So ito, CL negative. So, magiging ln u, right? So, ln u. So, magiging negative ln 5 minus x. So, let's substitute this to our function or equation. So, copy limit c approaches to 5, 1, 10. So, ito magiging negative ln 5 minus x plus same, so magiging ln din to 5 plus x. Our boundary, which is 0 to c, is equal to limit c approaches to 5, magiging negative 10 ln 5 minus x plus ln 5 plus x. And our boundary is z to 0. Next, let's make it as a 1. So magiging limit c approaches to 5, 1 over 10. To remove the negative, let's put this into the denominator. So magiging ln 5 plus x, 5 minus x, 0 to c. And now, let's substitute our, let's subtract the upper limit and the lower limit. So limit is equal to c approaches to 5, 1 minus 10, ln 5 plus c, 5 minus c, minus 1 over 10, ln 5 plus 0, minus 5 minus 0, is equal to limit c approaches to 5, 1 over 10 ln 5 plus c, 5 minus c, minus 1 over 10 ln 5 plus 0 is equal to 5, and over 5 minus 0 is equal to 5, so 5 over 5 is equal to 1. Now, let's apply now. Let's apply now our limit, which is c approaches to 5. Let's use another paper. So magiging 1 over 10 ln 5 plus 5, 5 minus 5, minus 1 over 10 ln 1 is equal to 1 over 10 ln 5 plus 5 is equal to 10, right? 5 minus 5 is equal to 0, minus 1 over 10 ln 1. 1 over 10 ln 10 over 0. Any number divided by 0 is equal to infinity, right? So minus ln 1 is equal to, ln 1 is equal to 0, and 1 over 10 so magiging 0 ito. So 1 over 10 ln infinity, ito magiging infinity. So 1 over 10 times infinity, magiging infinity. Therefore, the limit and the improper integral diverges. That's all for the coverage of finals in Calculus 2. Thank you for listening and God bless.
Disclaimer: I had a fever while recording this video, so my voice may sound different.